Well, hi, good morning. Thank you so much for joining me in my shop. Today is March 8th. And what happened at the end of the last video? Ooh, that's a question. So the dim bulb came on bright. Sorry that the camera was aimed over here, but you probably saw the light from it. Came on, looked to me, fully bright. I didn't really notice if the radio pilot light was still going. It all happened so quickly, didn't it? But a few minutes later, after I finished the video and was working on preparing the video for YouTube, my eyes went down to this area here, and it's different now, but I looked down and these two were pretty much in contact here like that. I think that's what happened. I mean, this is a pretty precarious arrangement here, and I shouldn't be too surprised if something bad happened to it. So, what to do? So, a couple options here. One is finish off this cable now. I'm going to have to do it sooner or later. Maybe I might as well do it now, and then it's secure, and then I'm not going to have a short develop. The other one is leave it like it is. Try to make it safe. Turn the radio on. See what happens. I think I should just go ahead and make these wires safe and secure, because this arrangement can't stand. I can't continue working with this like this. So that's what I got to do next. 4 wires extended just about this length, I think would probably do it. That's my first project here this morning. Okay, I think I've got 4 different colors of wire here, and I've got my shrink sleeves ready. So all I got to do is just one by one finish these off. These shrink sleeves have to be slid up the wires here. Do this right away because I don't know, have you ever done this and forgot? Yeah, don't tell me you haven't forgotten. I'm sure you have. So what I'm talking about here is forgetting to slide these up the wire before you make the attachment. And then once you've done the attachment, you can't get a shrink sleeve on. Very good. Okay, so I think you get the idea of what I'm doing. I am going to do it. Be done. Because I've been around myself for a long time, I know the kind of mistakes I make, and I'll end up putting in wires too short here by 1 inch. So to avoid that problem, what I've done is I've taken a piece of wire and kind of held it in the cabinet from where it's starting on the radio down to where it needs to get to. So ultimately, this is how long this cable must be. And so I'm going to use this to set the length in between here. So we go from here, come along. Okay, so I need to bridge that gap, and then I've got enough wire, surely to goodness, I can feed it through that cabinet. I looked at the cabinet again just to reassure myself there is a way to get the wire down. There's a big hole on the first deck, on the radio deck, but on the record player deck there's no hole. But I think I know how I can easily get the wires past it with the plug on the end, which is the challenge. You get the speaker on one end and the plug on the other. Something's got to go through the hole and then onwards. Anyway, okay, so that's all set. I will do this now. Okay, there we go. Got the splices done. Shrink sleeves are on, but they're not shrunk yet. Good. Not bad. Okay, let's shrink the shrink sleeves here. This is pretty exciting stuff, so I think I'm going to stop the video here so I don't get you too excited watching this. Okay, got the cable all done. I put these cable wraps on. It looks really nice. Big long cable. And it's time to operate the radio again. find out if it really was just a temporary little short circuit here, or if something more serious was going wrong in the radio. But I think first I'm going to go drink a little bit of coffee, and then we'll give this guy a go. Hey, it's going to work. No, it isn't. Is it? Getting myself all ready for an attempt at powering it up, and there's no power cord yet. Okay, let's put the permanent power cord on it now. Okay, so what I've done is I've taken the long cord that was on the back of the unit and simply soldered it in. So nothing wrong with this, it's in good shape. Not a polarized plug, but that doesn't matter on a unit like this, as long as I'm careful. And what I do, okay, we're going to plug it in. Now, the dim bulb system here is going to save me if I've made some kind of error. There's a chance I got something wrong. I was kind of careful. I don't think I did. I think I got everything right. But as usual, what I think and reality are two different things. So I'll certainly want to start this with the dim bulbs in place. Okay, power plugged in. Let me put this over here, get a better look at it. Okay, cable's here, it's plugged in, power's plugged in, wires are attached and soldered. Volume and on-off switch. So, whoops, that's a band switch. Oh no, it isn't. What, did that click twice? Was that my imagination? I must have heard this. That's what it must have been. Okay, so it's switched off. And still not sure who's who in terms of volume, and I'm pretty sure this is going to be the volume here. Okay, so the volume, so switched off. Okay, here we go. Power coming on. Nothing should happen. Nothing is happening. Very good. 116 volts being sent to us from the Darlington nuclear plant today. 3 big nuclear stations in Ontario. Okay, next step is switch it on. Maybe now, yeah, you can't quite see what I'm doing with my left hand here. I'm working the switch over here. This is it. We're going on now. This thing could just go back into the weird oscillation or whatever that was happening. Kind of a motorboating sound, kind of a farting sound, really. It may just go right back to that, or the problem really was just a temporary short here on my bench, and it's all gone, and we're back to where we were before the event. So I'm going to switch this on. The light's going to come on, going to go down, and then maybe come up again, and maybe we'll hear the radio, and maybe. Here we go. Okay, the light's behaving normally. That was normal. You see it come up bright and then go dull. That's the heaters on the tubes heating up. Now, from here it should get brighter, but it's restricting a lot of the power in the radio. We only have 78 volts reaching the radio right now. So consequently, the tubes warm up very, very slowly. There's that sound. Okay. I was not expecting that. So was that the kind of sound that, wow, something is really burning up in here, and if I leave the radio operating, something terrible is going to happen? I don't think so. Didn't sound that crazy to me. Yeah, I'm going to give myself a little bit of time to think about this before I go further with it. What I would like to know now is, can I power this up, let the speaker fart away, and take measurements and do stuff without risking anything? That's the question. There certainly is one thing I can do. I can always test the tubes without any risk. So maybe that's high on the list coming next. Not that I think tubes are related to this kind of problem. I really don't. But it's something I can do while I'm waiting for better ideas to come along. Okay, so I didn't even make it to my coffee yet. So what I'm going to do after I drink some coffee is I'm going to turn the set on. I notice that the sound doesn't come out of the speaker at first. So a tube has to come into operation before the behavior appears. There's a good chance the tube we're talking about is the rectifier tube, and what it's doing is it's turning on, as it heats up and begins to operate, it basically turns on the rest of the tubes with B+. At that point, something starts happening and we hear it coming out of the speaker. There is a type of feedback or oscillation in a radio called motorboating. That's what this could be. This could be an example of motorboating with the motorboat engine running really fast. Sometimes if it is motorboating, it'll actually put like that. But this is just kind of roaring along, but it could be the same thing. That would be a problem that's because of worn out components and stuff like that, and you really can't get rid of that until the right component is replaced, or components, could be more than one. In terms of operating the radio and it's actually burning up while I'm standing here pondering it, in order to avoid that from happening, I'm going to use my thermal viewer here. This is a heat sensitive camera, and I can look at the radio and see if there's something getting very hot before I start thinking there's really no problem with operating the radio continuously. Things you want to worry about: that transformer right there is similarly the big transformer that's feeding the whole radio. You don't want to worry about those things, because if you cook those, and it takes a while to cook them up, but if you did cook one of those and ruin it, that's a tough part to get and replace. Everything else, yeah, except for the transformers and coils that are in here, like this coil, everything else can be replaced, but not the coils. Basically, the coils are a big problem. Coils like this. So I can also watch this and see how hot this is getting. Likewise, there's a coil in here that's also carrying a fair bit of current, and normally this will warm up a little bit. A little bit being the operative term there. So that's the plan. I'm going to go away and think about this a little bit, because thinking is good in situations like this, and coffee's good too. Coffee for health. Yeah. Okay, couple simple ideas here. One is to turn the band switch to the phono setting, and that will cut off a large amount of the circuitry in here from reaching the speaker. So even if the thumping sound is still going in the radio, it may not come out the speaker. This will tell me a little bit about where the problem is. It can't really be, well, I was going to say it can't be in the audio circuits, but I don't know that for sure. So we're going to try that. Looking for hot stuff. Yeah, hot stuff. Looking for hot stuff. So it takes time for things to heat up. You can't do that instantly. But I'll get my gizmo ready here. This is very hard to show on camera. I will try. And we're going to have to set this so we want to spot hot things, so I can control what's red and what's green on this. You know, red is high and green is cold. Blue is actually the coldest color. So I'm going to set this to, so red will only show up when the temperature of the thing it's looking at is around 35 degrees C. Maybe a little higher, because we're looking for a real problem here. I'm going to go even higher yet, 45. So probably start turning red a little bit below 45 degrees, but the red stuff will be hot, that's for sure. Everything else can appear blue. How can I prove this to you? What about my hand? You see my hand is, you can see the color changing there. You see my fingers? Yes, you can see my fingers there. Not red though. Okay, maybe I went a little too high with that number. I'm going to just pick it down one. Okay. There's something already warm here. Yeah, this box is a little bit warm. Normal warmth. Okay, I think we're set. Then another thing I thought of was, does the volume control, tone control have any impact on this? just something worth looking at. Does tuning the radio have any impact on it? This must be the switch here. Come to think of it, I was thinking the band switch would be this switch. The band switch goes one position, two positions. That's it. It's just okay. So it's this switch. Okay, so I think it was in the up position, wasn't it? Was it? Did I move it? Uh-oh. So much for science. Here we go. Remember now, no thumping until things warm up. Things warm up slow because the lights are in. Things warm up, the thumping starts. What am I doing then? Well, what am I doing? I'm working the volume, I'm working the tone, I'm tuning the radio. Anything else I need to do? Then looking for temperature anomalies, which I don't think are going to be in the radio at all, but we'll take a look. That's what we're going to do. And the whole time this thing's going to be making sound. There we go. Okay, so dim bulb comes on. No sound. So we know it has to involve the tube operating. So tubes are slowly heating up. 80 volts. Maybe that's why this wasn't so loud. I had the voltage very low here. Ooh, that's interesting. So you can see volume does make a difference. Almost for sure this is motorboating. Volume control is a little dirty. Gentlemen, start your engines. Some of that I think is a scratchy sound. It's not. It's not dirt. This reminds me of a joke. The co-pilot and the pilot are listening to their engine sound like that, and the co-pilot says to the pilot, "I don't think we're going to make it." And the pilot says, "Don't worry, we're certain to make it to the crash site from here." That's my joke. I'm the worst joke teller in the world. Let's try the tone control now. Everybody's having an effect here. Sounds like my cat purring. Ah, that's right. We got a purring radio. Now we're going to take a look. Something so we can see something right in the middle here. What am I looking at? So it's on an angle like this. It's this resistor here and the temperature. So the way this guy works, it will report the highest temperature here above my finger in red. You can't see it. The print is so small. The highest temperature on the screen right now is 40 degrees. You can actually see the number coming up here. 40 degrees, that's okay. That's nothing to get too excited about. Of course, I'm running the radio with low. Oh, only at 74 volts. Well, that could be why it's doing this right there. We're going to give it more voltage here. Nothing is burning up. Nothing is going wild. Okay. So the way I'll give it more voltage here on the supplies, I'm going to screw in the other light bulb there that you see, this dark one here. When I screw it in, it's going to allow a higher voltage to reach the radio, or more current to reach the radio. It's going to make this sound get worse and louder. So I better close my door. I don't want to disturb the neighbors. Okay. Are we ready to do this? He says, yes, I think so. So I'm going to keep an eye on the voltage here. It says 74.2 right now. Here we go. Sounds like a helicopter. 86 volts. We're still way low. Generally, I find radios start to operate normally around 90 volts, but not necessarily. Okay, I can force this up a little higher. I want to keep these bulbs in because of what happened earlier, yesterday, with the sudden short, just in case. So I'm going to crank it up here. Using this now. Crank it up. We get to 100 volts. She's really pounding now. So that didn't help. So we're going to take it back down. Heated that resistor up a little higher, I'm sure. It's at 55 now. It's probably coming down in temperature since I cut the, 90 volts. So, you know, typically these kinds of radios operate. Okay, there's something else that's warming up. So there's another resistor right here. It's black. You can't see it in the camera. It's sort of pointing right at it. And that's also showing up with some heat, but that's a high wattage resistor. I thought there was one up here in the back too, but I don't see it. Just this one, just this guy here is getting hot. Good, okay, well I don't think we have to worry about something is burning out in here while I'm fooling around. What about these guys? What about these guys? Well, in fact, really, your hand is a better test here. No, there's no heat building up in these at all. Well, how to approach this? Let's measure the B plus voltage while we can. So B plus is a very high DC, like battery type voltage. Usually in these radios, 250 volts in that range. Can be higher. So we're going to look right on these capacitors here. This is probably where the high voltage will be. I see both these capacitors, the negative lead goes right to the chassis here. Negative lead, right to the chassis. And pick either one. So 200 volts. Oh. Why would that change? I'm just picking a voltmeter reading. How could that change it? So almost 300 volts sitting there. And you know what? I've got this radio running on 90. So we run this radio at full voltage, and this is going to become 3 something. Now, why did it change the pace? What happened there? I really not want to stick my finger in there, so I will get a stick. I was touching this. Well, a reasonable guess is there's something wrong with this part. Every time I touch this part, things change a little bit. These are the main filter capacitors here. If these were not working well at all, I think we would hear a hum along with this popping, but maybe not. Anything else sensitive in here? bad boy. Giddy up. When I was a kid, I learned a lesson in life, and that is that there are some things you keep doing, and if you don't stop yourself, something else is going to stop you. And that was me banging around in here. Sooner or later, something is going to pop or whatever. So I don't really know what's going on. For some reason, this capacitor seems sensitive physically to movement. It affects the operation of the radio. Hard to explain that one. So I'm on my way to replacing this and probably this almost right off the bat. Don't know that these are bad. These are replacements already that have been put in. These might be junk box replacements for all I know. Some guy grabbed them out of his box, and they've been in another radio before they were here, or they could be brand new. I don't know. The work looks okay, but something going on here. Okay. That's it for today. Tomorrow we'll deal with these filter capacitors and try to get the motorboating out of the radio. It can be quite challenging. You may have to just, start replacing capacitors and hope to hit the one that's causing the problem. That's a little ways down the road. Tomorrow it's the power supply, filtering, and we'll see if that maybe solves problems here. Thanks a lot for watching, and enjoy your day. I will enjoy mine.